So question number 6. The diagram shows the cross section of two drawer handles. Shape X is a rectangle ABCD joined to a semicircle with BC as diameter. The length AB equals D and BC equals 2D. Shape Y is a sector OPQ of circle with center O and radius 2D. Angle POQ is theta radians. Given that the area of the shape X and Y are equal, prove that this is equal to this. So if we have equal areas, so let's say area of shape X, which is 2D times D rectangle plus half of the semicircle, that is pi r square over 2, and that equals the other side, which is 1 by 2 r square theta, and we have to show that theta is equals to this. So I'm going to make theta the subject of the formula. So this is 2d squared plus d square pi by 2 is equals to 1 by 2 into 4d square theta. So taking t square as common, I'm left with 2 plus pi by 2, and on the other side 2 1 times 2 2 times, that is 2d square theta. So d square goes with d square and I'm left with theta. So we divide this 2 on the other side, becomes 1 by 2. 2 plus pi by 2 is equals to theta, and the angle is 2 by 2 is 1 plus pi by 4. First part done. Second says using the value of theta and given that d is equal to 3, find in terms of pi the perimeter of x. So we have this value of theta and d is 3 now. So we're going to find the perimeter of shape X. So which is 1, 2, 3, 4 sides. So 2D plus D on top plus pi R on the other side. 2 pi R for complete and pi R for half. Plus D again. So 1, 2, 3, 4 sides. Value of D is 3 plus 3 plus 3 pi plus 3, and we are left with 2 3 times 6 79 10 11 12 plus 3 pi. And the perimeter of shape Y. Shape Y consists of 3 sides to be added, 2D, 2D and the arc. So for shape Y, this is 2D plus 2D plus S equals r theta for arc length, where r is 2D and theta is what we found in the second last part. So 2 into 3 plus 2 into 3 plus 2 into 3 into value of theta was 1 plus pi by 4. So 2 3 times 6 plus 6 is 12. 2 3 times 6 into 1 is 6, and 6 by 4 pi. 18 plus 3 by 2 pi. D part says hence find the difference in millimeters between the perimeter of X and Y. So we have the two perimeters. Perimeter of X is right there and perimeter of Y is this. So we just subtract them and convert it into millimeters to find the difference. That was in centimeters. So let me just write this here in decimals. Let me get my calculator. Okay, so 12 plus 3 pi is 21.4247 centimeters, and 18 plus 3 by 2 pi is 22.7123. So when we subtract these two to get the difference, 22.7123, if I just multiply it with 10 and say that it is directly converted into millimeters, minus 21,214.247, and difference in millimeters. So this is already in millimeters, 227.23 minus 214.25 approximately equal to 12.98 millimeters. Any confusion? Question 7 says the diagram shows a circle with center O and radius 6 centimeters. The chord PQ divides the circle into minor segment R1 of area A1 centimeter square and major segment R2 of area A2. The chord PQ subtends an angle of theta radians at O. Show that A1 is equals to 18 theta minus theta. Okay, so this angle right here is theta, and we are talking about A1, that is this R1 shaded area. So this is basically this complete sector minus triangle. The complete sector is 1 by 2 r square theta minus 1 by 2 AB sine C, which is again r into r, and sine of inclusive angle is theta. So value of r is given, which is 6. So 6 square is 36 by 2 theta minus 36 by 2 sine theta. 36 by 2 is 18. We take out 18 as common. We are left with theta minus sine theta. First part done. Second says given that A2 is 3 times A1, show that sine theta is equals to this. So A2 is the area this was R1 area A1 and major segment. Okay, so A2 is this white part, all of that white. So I'm going to find the area of A1, then we'll multiply this and equate them. So on the right hand side, this is actually 2 pi minus theta. So arc 1 by 2 r square theta. In the case where r is 6, angle is 2 pi minus theta for this complete section, and we add this triangle to it, which is 1 by 2 AB sine of C. 1 by 2 AB again, that is radius, and sine of this angle, that is theta. Let's simplify a bit. 36 by 2 is 18 times 2 pi minus theta plus 18 by 18 sine theta. So this is the area of A2, which is 3 times area of A1. So when we bring this out, this is A1, let it be here, 3 times A1 is equals to A2. Now 3 times 18 times theta minus sine theta. On the other side, we have 18 2 pi minus theta plus 18 sine theta, and we have to make sine theta the subject of the formula. So let's simplify. I think I need more writing space. So this is 318 theta minus sine theta is equals to, I'm taking out that 18 as common, and left with 2 pi minus theta plus sine theta. So it is being multiplied on both sides. I'm getting rid of this 18 and multiplying 3 inside. That gets 3 theta minus 3 sine theta is equals to 2 pi minus theta plus sine theta. Taking sine theta on one side, 3 theta, bringing theta on this side, minus 2 pi is equals to sine theta plus 3 sine theta. That becomes 4 theta minus 2 pi is equals to 4 sine theta. Dividing by 4 on this side, 4 theta by 4 minus 2 pi by 4 is equals to sine theta. Sine theta is left with theta minus pi by 2. And what was that? Shown. Sine theta equals theta minus pi by 2. Triangle ABC says AB is equals to 9 centimeters, BC is 10, CA is 5. A circle center A radius 3 centimeters is intersects AB and AC at P and Q. So this is 3. Show that to 3 decimal places BAC is 1.504 radians. Now BAC, this angle, we can find this angle using cos rule. So cos of BAC is equals to 10 squared minus 5 square minus 9 square divided by minus 2 into 5 into 9, and BAC is cos inverse of this answer. So to find BAC, we are using cos rule, and this answer is 1 by 15, and cos inverse of 1 by 15 is 1.50408, which is approximately equal to 1.504 radians. Second part says calculate the area in centimeter square of the sector APQ. APQ. So which is 1 by 2 r square theta. We have all the values. This would be 1 by 2 r square, and theta is 1.504. Which results in 6.768. Second part, the area in centimeter square of the shaded region. So shaded region is full triangle minus this sector. So which would be full triangle is 1 by 2 A B sine C 1.504 minus the unshaded part, which is 6.768. 0.5 into 5 into 9 into sine of 1.504 minus 6.768, and shaded area is 15.68 centimeter square. Last part says the perimeter in centimeter of the shaded region. So perimeter, we have 1, 2, 3 and 4 sides. CB, let me change this color. So CB is 10 plus this right here is 2. Full is 3, radius was 3. Full is 5, radius was 3. So 5 minus 3, this is 2. On this side, 9 minus 3, this is 6. And this is S equals R theta. R theta 1.504. And then use of calculator, 10 plus 2 plus 6 plus 3 into 1.504, and that is 22.512 centimeters. Any confusion? Question number 9. The diagram shows sector OAB of circle of radius r centimeters. The area of the sector is 15 centimeters square. AOB is 1.5 radians. Prove that r is equals to this. So we have the area, and let's use these values. 1 by 2 r square theta is equals to 15. So 1 over 2, r square is unknown, theta is 1.5 is equals to 15. So 1 by 2, r square is equals to 15 divided by 1.5 is 10. R square is equals to 20, r is equals to square root 20, and square root 20 in calculator is 2 square root 5. Proved. B part says find in centimeters the perimeter of the sector OAB. So OAB, we add all three sides, which is r already shown 2 square root 5 plus 2 square root 5, and AB arc is S equals r times theta. So 2 square root 5 times 2 plus 2 square root 5 times 1.5 is 7 square root 5 centimeters. The segment R shaded in the diagram is enclosed by arc AB and straight line AB. Calculate to 3 decimal places the area of R. So this is complete area minus area of triangle. Complete area is 1 by 2, which is given 15, which is already given. So that is 15 minus area of triangle 1 by 2, 2 square root 5 AB sine C and sine of 1.5. At all times make sure calculator is in radians mode. And we get 5.025 centimeter square. Question number 10. The shape of a badge is a sector ABC with circle with center A. The radius AB as shown in the diagram. The triangle ABC is equilateral, okay, and has perpendicular height 3 centimeters. Find inserts form the length of AB. So this is already equilateral, so this should be pi by 3, that is 90 degrees, or pi by 2, and this angle right here is pi by 6. So we can use any of these to find AB. If I'm using pi by 6, I'm using cos. So cos of pi by 6 is base over hypotenuse, which is AB. So AB is equals to 3 divided by cos pi by 6. So cos of pi by 6 is square root 3 by 2, and 3 divided by answer is 2 radical 3. So this is our radius AB. Second says find in terms of pi the area of the badge. Area is 1 by 2 r square theta, and this complete is pi by 3. So squared divided by 2 divided by 3 is 2 pi. C part says prove that the perimeter of the badge is this. So we just add all three sides. The radius is already there, 2 square root 3 times 2, and BC is S equals r theta. Radius is 2 square root 3 and radius is the angle is pi by 3. So 2 square root 3 is already there, we just take that out as common, and I'm left with 2 plus pi by 3. Bringing this 3 out is 2 square root 3 by 3, 6 plus pi. Shown. Any confusion? Not any. Question number 11. There is a straight path of length 70 meters from the point A to point B. A to B 70 meters straight. The points are joined also by a railway track in the form of an arc of the circle whose center is C and 44 meters is the radius. Show that the size to two decimal places of ACB is 1.84 radians. So again, cos rule, we have all three values. So cos of ACB equals 70 square minus 44 square minus 44 square by minus 2 into 44 into 44, and ACB is equals to cos inverse and calculator. So 70 squared minus 44 square minus 44 square by minus 2 into 44 into 44 is negative 257 by 968. Cos inverse of answer is 1.8395, approximately equal to 1.84. B part. Calculate the length of railway track. So that is arc length. It should be S equals R theta. Radius is 44. Theta is 1.84. And arc length is 80.96 meters. The shortest distance from C to the path. So this is the vertical distance right here. So the half of 70 is 35. I'm using Pythagoras theorem. 44 square minus 35 squared whole square root. This is 3 square root 79, approximately equal to 26.7 meters. Third says the area of the region bounded by the railway track and the path. So again, complete area minus area of triangle, and complete area is 1 by 2 r square theta minus 1 by 2 AB sine of C. 0.5 into 44 square times 1.84 minus 0.5 into 44 square into sine of 1.84 is 847.98 meters square. A teacher asks a student to find the area of the following sector. The attempt is shown below. Identify the mistakes he made. So this is 1 by 2 r square theta. 1 by 2 is there, r square theta. Radius is 3, that's correct. This is the mistake. Angle is actually in degrees. You should have converted it into radians. And how do you do that? Pi radians is equal to 180 degrees. So when we need this is unknown, that is 50, and we cross multiply, this would be 50 pi by 180. We should have used this value. Calculate the correct area. So we just plug in the value in radians, or we use the formula we did in IGCSE. So 50 pi by 180. Either we use this, or we write angle by 360 times pi r square. So we can use any of these. And that is 3.926 centimeters square, or in the exact form 5 by 4 pi. Chapter complete.